right, so we can get started. We are here to explore vibe coding. We basically want to find out if indeed one can develop a fully functional web app, um, you know, without touching any single line of code, just giving commands. And to start us off, I have Chakula here working, and I just want to take you guys through the architecture. Given that Chakula is, a real world use case or a real world application. So we have a couple of things. Number one, we have the Chakula mobile app. Oh my goodness, I do not have libraries here. Let me just do this. All right, so we do have the mobile app for maybe iPhone or Android, and we do have a website. So let me just look for a website icon. So let me just draw here website. Yeah, I recently installed this Windows, so it still has a few things missing, but we'll just move on as we explain. So Chakula has an Android app, and Chakula also has a website. The website is for people who are using their desktop, and we can give them labels. So we can say this is the website. Let's say, for example, chakula.co.ke. So this is our website. And then we have the Android and iOS app. This is the mobile app. Now, both the website and the mobile app, they both have one backend. Remember, when you're talking about front end and backend, both the mobile app and the website have one backend, which is what we are going to put at the top here. So this is our backend. Okay. Now, our backend consists of a few things. It's not just the backend. It's not just one service like Flask API or something. So we are going to say this is our backend. Now, when you're developing any application, be it mobile application, web application, there are a few things you need to ask yourself, or there are a few factors we need to consider. Number one is scalability. Number two is security. Number three is speed, and number four is what I have forgotten: scalability, security, speed. What is number four? These are factors to consider. I have forgotten number four. Does somebody remember what number four is? Let's see. Oh yes, reliability. Now think about any software you're using right now. There is an element of all this in any software you're using right now. Let me just put this. Okay. If you're using a banking app, for example, Coop Bank, okay, scalability is more of the engineering side, more of the owners of the app side. But since we are software engineers here, we can just think of it like, is the mobile app scalable? Is the platform scalable? Today we have 10,000 users using our app. If tomorrow we have 100,000 users, will our app sustain the load? Will it be able to handle all those requests? And you can think of it this way. Remember, we do have KRA. And, like right now, if you try to file your returns, everything works okay because not a lot of people are filing their returns. But if you have a lot of people filing their returns and you go and try and file your returns, especially when is it in June, the website is a little bit slow. It's sluggish. Sometimes it doesn't, work as you expect. So we ask ourselves: is our platform scalable? Is our platform secure? If I have if I have some Delta's bank credentials and I try to log into their account right now, will I be able to withdraw their money? Is the app fast? If I'm trying to pay for Uber, for Boda, you know, I've been I used a Boda from, let's say, for example, Upper Hill to Imenti House. Imenti House is crowded as hell, and you have to be fast and you have to be very careful. So you only have one chance to, you only like have seconds to make that transaction. So is the app fast? Is the app reliable? Is it something I can say M-Pesa is reliable? I can rely on M-Pesa. So when you're building any software, this is what matters. Okay, that light is giving me a lot of heat. Let me take off my hoodie. All right, so to achieve these things, you need more than code. You need more than just writing a function, define, calculate balance, define, find location. You need more than that. You need other tools that will help you achieve these four factors right here. So our backend is a little bit, it has quite a lot of services. Number one, we have the main API. Remember, when we are building APIs, we have the main API which serves our requests. So we can have the API right here. And I think I have to resize this backend and probably move it a little bit up. All right, so we have our main API here. But for us to make our main API secure, we cannot just deploy it as it is. We need something. We need something called a reverse proxy, and we need something called a firewall. So we create our firewall. So right at the bottom here, before any request gets to our backend, before the user makes request to our main API, they have to pass through a firewall. So let me just say this is our firewall. This is our firewall. Let's move it up here. All right, and then any request that wants to hit our API, it will have to pass through a reverse proxy. So we can put our reverse proxy right here. Reverse proxy. Okay, and all these are applications. Don't get confused, trying to figure out what these things are. All these are just applications. If you Google a reverse proxy right now, if I say, for example, reverse proxy, we have Nginx, we have Kadi, there's quite a few. We have Nginx here, the most commonly used reverse proxy. If we do something like web firewall, a web firewall is just, again, like an application you download and you install on the server. So we have a reverse proxy, we have a firewall, and I want to change this firewall to have something like that. So we have a firewall. Now, our API does not just handle requests. As you have already seen somewhere, Chakula uses some sort of AI to generate your meals, and also to, the API is not working right now, I know for sure, but let me just try. So I'll choose my location, I'll choose my budget, daily meal budget. I don't think the API is working. I haven't set everything up yet. So we have some sort of an AI, which is what we call our knowledge base. So this is what we call knowledge base. Knowledge. By the way, the source code for Chakula is open source. You can go to GitHub, just search Chakula on my profile, and download the code and play around with it. If you want to steal it and build the app, fine by me. Anyway, so how does this communicate? Okay, how does this all work together? Now, imagine a user is on the website and they want to get their meal suggestion. What will they do? They will send a get request. Remember, get and put request, and post request and whatnot. So the user will send a get request to our okay. I really need to have created all this before the class. So a user will send a GET request to our backend. Okay, remember the user does not know what a firewall is. The user does not know what a reverse proxy is. The user does not know what an API is. The user does not know. The user does not care about your AI, whatever running inside your backend. The user only cares about the answer they want and where they're sending the request. So the user will send a request, and the backend will respond with, a response saying, "Hey, your request was successful," and it will respond with suggested food. All right. Again, why is this important? Before you build any software, like I said, you always start with a why. Why are we really doing this? And for you to understand the why in detail, you have to understand how the information flows, how everything flows in the actual world. So right here, we've already identified our, we call it a user journey. The user will go to the website, they will log in, and then they will send a GET request to get food suggestions, and then our backend will respond with the suggested food. The same applies to if the user is using a mobile app. So I can just copy paste this, put it here, do this, do that. Okay, so both these users will sort of have the same flow for getting a food suggested to them. And here really I can just replace this with an actual food. So let's say ugali omena. Okay, and let's assume the user using a website is a different user with a higher budget. So maybe they will get pizza and Coke. All right, so these requests go to our backend, but our backend has 4 services stack up on top of each other. And I'll show you an actual example how Soma stories is sort of layered. So now inside our backend, the request will pass through a firewall. Now the firewall will only do one thing. It will check the request. Is this request genuine? Is it somebody trying to hack our system, or is it a genuine user trying to get food? And it does this through so many methods. For example, it might check the number of requests. We call this a client. So anytime I say a client, just know I'm talking about the user. So it will check that request the client is sending. Is the client sending 100 requests in 1 second, or is the client sending only one request? Apart from that, it will also check the structure of the request. Is this a genuine request? Does it have normal parameters that we want? Now, if this passes, if the firewall passes, the request will go to now the main API. What am I doing? My goodness. The request will now go from the reverse proxy, from the firewall to the reverse proxy, and then the reverse proxy will just sort of forward the request to the API. Okay, the reverse proxy is very useful. For example, how can I explain this? The reverse proxy, we'll get back to that. And then the API now will determine, is this user trying to generate mails? Does the user already have mails generated? If they have mails generated and we have it right here, there is no need for us to go to the knowledge base. But if we do not have the food, we go to the knowledge base. Okay, so the API will send a request to the knowledge base, and the knowledge base will respond with the generated food. Okay, so it will respond like so, and then the API will respond to the reverse proxy. So now when we are sending the request back to the customer, there is no need to go through the firewall. We can just send the request as it is, because it's us communicating with the client. So there's no need for a reverse proxy. So we can just do that. So now this is the response. Okay, and maybe I can just change this to green. So this is just the same as this green you see here. So we can just do that. It's duplicates, but I just want you to understand what's happening here. The same will happen to a user using a mobile app. Now, all this looks very confusing because, okay, so what exactly is happening here? Okay, all this looks very confusing. Now, let's look at an actual project, Soma Stories. Of course, I know most of you have already downloaded the app. You've played around the app. And I'll just open the source code for story here. GitHub. I can just type Soma here. So as you can see, there's quite all these are projects related to story app or Soma stories. When you upload a story, or when you unlock a chapter, or when you read a story, all these services work together to deliver to deliver whatever you're experiencing on the app. So we do have the main API right here. This is our main API, okay? And then we do have the mobile source code right here. This is the mobile source code. And we do have the Mobi. Mobi is another service that sort of just sends emails and push notifications. So if you've gotten a push notification saying, hey, your token is low, or hey, would like you to come back and read a story, that is not the main API. That is Mobi, this one you see right here. And then we have the admin interface, which is, for administrators or moderators to log in, moderate content and whatnot. Now let's draw this setup. So we'll just reuse the same thing. So let me just do it right here. All right. So again, it's the same flow. We have the Soma Stories website, somastories.app, and I do not like that. Let me do www.somastories.app. All right, so we do have somastories.app, and then we have the story app, all right? And in our case, we are dealing with stories. We are not dealing with food, so I'll just delete that. We are dealing with stories. Now, the setup remains the same. Your request will go through a firewall. The firewall will forward your request to a reverse proxy. The reverse proxy will forward your request to the API. Now, the API will fetch the database. It will not fetch the knowledge base because we don't have the knowledge base in our case. In our case, we have another service. It's still part of our backend, but it's a whole new service. And I just want to move it to the side here and move it back here. So, in this scenario, the API will talk to a database. Let me look for a database icon here. So let me browse. All right, so the API will talk to a database. So assuming you want to read a story, you have identified a story, or you have a link, you want to read that story. So you'll send a GET request to the backend. The backend, of course, your request has to be, it's like a watchman. Your request has to be, what do you call it? Assessed or something. And then your request will go through the reverse proxy, and then the reverse proxy will forward it to API. You can actually try this right now. You can go to Soma Stories website and try to log in using the wrong password. You will only have 5 attempts, and then it will give you a break. It will ask you, hey, you're doing this too many times, take a break. That is the work of a firewall, okay? It tries to check your request, and using parameters we defined, it checks, is this a genuine request, or is it just somebody trying to hack the system? The same applies to when you're making any request. For example, if you get the API to upload a story, and then you send like 10 stories in 1 second, the firewall will block you. It will say, hey, you're doing this too many times, stop there. So I really want you to pay attention to what builds a system. So this is the knowledge, this is not the knowledge base, this is Mobi. So this is Mobi, and Mobi is just a separate service. It does not care about the API, it does not care about the reverse proxy, it does not care about the firewall. What Mobi does, Mobi goes to the database, and it's actually some sort of machine learning. It goes through the list of users and tries to find out which user has never unlocked a story. Okay? Which user has never topped up their account. So it could be, for example, they are having problems topping up their account, or they just don't know how to top up their account. And you can see this in mostly other applications as well. I normally get notifications here from TikTok, and I just want you to show the notification. Where is it? Okay, so this is the creator update, and as you can see, they send me notifications on the performance of some of the videos I upload. Okay, so you can think of this as just a separate service that helps your backend with this kind of things. Why are we having a separate service? Why can't we just have the API send the push notifications? It's because you will overwhelm your API. Okay, you'll overwhelm it with too much work, and sometimes it gets slow or sluggish when users are using your service. So this is a general overview of a real world application. Now let's look at another one. It's very important that we understand this concept right here. Bernard, sound is low. Is anybody else having trouble hearing me? Royal Molo and Delta. No, Chakula app is not available yet. Yeah, I'm still trying to perfect a few things. Hopefully by the end of this month, we'll have it running on Play Store. I welcome you all to be part of it. So just download the source code. It's right here on GitHub. The instructions on how to run is a little bit over the place. I haven't done much. So if you just go to my profile, you can just search Chakula and you'll see we have the knowledge base, we have the API, and we have the Chakula mobile app. So this is the source code for the mobile application. This is the source code for our main API, and this is the source code for the the food generator, what now stores the foods. Okay, yeah, so you can have a look at it. So let's have a look at another example. Let's see, for example, Coop Bank. Okay, so Coop Bank, the same thing. Let's copy this. Let's move it over here. All right, so this is Coop Bank, and this is what we normally call a high level system architecture, or just a design brief for your system. So Coop Bank, they do have a mobile app. So let's say this is the Coop Bank app. Okay, and they also have okay, I've had a notification. I thought it was one of you guys sending a donation. Anyway, you guys refused to send me donation, but it's okay. It's okay. Anyway, I'm joking. So Coop Bank also has a mobile a website. Okay, Coop Bank. I don't know what the website. I don't know the domain. coopbank.com. So let's have a look and try to understand how many platforms do they have for the web application. So I'll go to the browser right here. I'll just search Coop Bank, Co-operative Bank, Coop Bank. Okay, so they have the main website, which is Coop Bank. So let me just delete these contact us. Please, if Coop Bank is watching this, I'm not trying to do anything malicious. As a matter of fact, I'm marketing you guys. Okay, so we have quite a few things. We have banking for me, banking for business, and whatnot. We have all these options right here. We have the sign in to internet banking. So I'll just open this in a new tab. And as you can see, this is a different domain. This is onlinebanking.coop.com. So I will copy this. I'll go to our and then I'll copy this. I'll put it here. So they have another service for in online banking, which is right here, apart from the main one. So I'll just say www. All right, so let's go ahead and try and see if they have anything else. So we have personal banking. So you pay attention to this if it will change. Personal banking, again, as you can see, this is retail online banking. So it's a whole new platform. So we'll copy it. We'll go to our document and we'll, okay, what now should I do here? Let me just move this over here and then move this over here. All right, so this is www. All right, and then they have the mobile app. So we'll just do this for the mobile app. Now, in this case, we can work on assumption, because if I come here and I try to log in a few times, I'm pretty sure it will lock me out. Okay, so if I just change my password like so, I try, said invalid. I try again, invalid. I try again, invalid. I try again. Aha, your account. Oh my goodness, my account is locked. My money is gone. Anyway, your account is locked. Click the self service menu below or call customer support on this. I am pretty sure I will regret this, but I'll get to it later. So this is the work of what we call either it's a firewall or it's another service that tries to determine this person sending requests to our service. Are they genuine? Oh, Noah Ali. Okay, glad to see you, buddy. Tech Innovations, Learn CTX is the project name. Is that capture the flag? Anyway, we'll get to that. So Coop Bank has all these web apps. They have the main Coop Bank app, they have the retail online banking, and they have the online banking. Okay, all these do have the same backend, because if I log into the online banking and if I log into my Coop mobile app, I will see the same amount of money on both the platforms. It's because we are using the same backend. And as you have seen, you cannot just try to brute force. What I've done here is an example of what we call brute force attack, where a hacker tries to guess your password, you know. They just try to guess until they get the right password. So this is a protection against brute force attack. Just keep that in mind. And then it passes through a firewall, of course. It goes through a reverse proxy, and then it gets to the API, and then it gets to the database. So if I want to get my bank balance and I'm using the mobile app, it will be the same thing. So I'll send a GET request to the Coop backend. My GET request will first pass through the firewall to be, checked, and then it will go through a reverse proxy, and then it will go to the API. It will go to the database. So this is the architecture of most web applications, or we can just say most systems. Okay, so let's look at another example of an ERP. Now we are moving away from web applications and we are going to the world of ERPs. If you guys have ever worked with any ERPs, for example the ones they use in supermarkets or in big companies, it's some sort of distributed computing where in the office you have one computer which you're going to call it the server, and the server has the database, and it has the I want to delete this thing. All right, so we have the main ERP system, and then we have our backend, our database. So we are going to call this, like a common ERP system is what we call Sage 300. So this is Sage 300 ERP. Or it could be anything really, like Odoo, Zoho, anything really. So what happens is the company has one main computer, which is the main server. So we are just going to call this main server. All right. And each workstation, anybody, somebody working, from the reception, somebody working in finance, somebody working in sales, they will access all the content stored inside the ERP. So we'll have something like, so we'll call them nodes. Nodes is just a fancy name for computers on a network. So we have several nodes. So we can call this node 1. And I know some of you are wondering, this was a vibe coding session. Why am I going into other things that is not vibe coding? We'll get back to there, and you'll see why going through this is very important. So we'll have node 1 here. Or we can just call it node A, and then we have another one here. So node A reception. This is node B. This is, for example, finance, office, and then we have another node here. This is the managing director. So we'll say this is the MD. So we'll say this is the MD. So now remember, an ERP is enterprise resource planning. It's common in almost any major business you go to. If you go to a company like Doshi, they're using an ERP. If you go to a company like Safaricom, they're using ERP. Actually, Safaricom is using Oracle, if I'm not wrong. If you go to a company like KPLC, they're using ERPs. And this is the part that is less taught in schools and even in online tutorials, but it's very common in almost any company. They have an ERP. If you're also planning to run your business, do explore ERPs. Try to understand what they are and what you can do with them. Now, let's have a look at what an ERP does. The person at the reception will get a customer walk-in. I'm trying to draw an arrow. Where is my arrow? My goodness. Okay, it's too tiny. So this is a customer. They've walked into the business. We call this customer 1. All right. Customer 1 wants to purchase something. Customer 1 wants to purchase, for example, what do they want to purchase? They want to purchase a microphone. Okay. So they want to purchase a microphone. Now, the receptionist will not call somebody in finance to ask, hey, how much do we sell a microphone for? No. They will go to the ERP and they will check the price of a microphone. Once they have the price of a microphone, they will tell the client, yes, we have the microphone, but it goes for this amount of money. So we'll say microphone price. We'll say microphone price. So we are asking the ERP, how much is the price of this microphone? And the ERP will reply with, the price of this microphone is 12,000. All right, it's 12,000 Kenya shillings. Now the receptionist will talk to the customer and tell them, hey, the microphone is 12,000 Kenya shillings. You can pay using this M-Pesa pay bill, and the customer pays. So after the customer pays, the receptionist will, okay, it's not the receptionist's work to do that, but just stay with me here. So the receptionist will send another request to the ERP, to the server, to the main server, telling the main server, hey, there is a customer who has bought a microphone worth 12,000 Kenya shillings. Now, the person in finance who handles the finances of a company will check the ERP and find out, so on Monday, we did sell a microphone at 12,000 Kenya shillings. How much money did that make us? What was the profit of that sale? The profit was this much money. And then they will say, okay, so if we are making a profit of 4,000, how much should we pay our employees? So the finance of, okay, it's not the work of the finance person to pay, but just stay with me again. So the finance will say, hey, we've made a profit of 4,000. We've paid taxes of 1,000. This is our tax returns. This is our standing. This is our our debt. This is whatever, or anything to do with finance. Now the MD would want to know how the company is performing. Now remember, the MD does not care about this customer. Okay, they do because it's their customer, but they don't care about exactly what this customer bought, the interaction between the customer and the receptionist. They only care about how much money did we make. Are our taxes well filed? Are we making money? Are we making losses? That is what the managing director cares about. Again, the managing director will query the ERP software. Now, from this scheme, is it a schematic? No, it's not a schematic. Let me just do this. Again, let me just do this. All right. So you would imagine all these requests will go to the same server in a matter of milliseconds, okay? And if the company is big, if the company has, like, let's say 10 branches, 1,000 employees, all these employees are making the same request, okay, not the same, but they're making requests to the server all at the same time. So that means, number one, your server has to be extremely powerful. And I'll show you the example of a server. So we can just say on-prem server. So on-prem means the server that is hosted locally on your premise. Okay, HP ProLiant. I know one called HP ProLiant. It's this one right here. This is an example of a server. I think this looks a little bit better. This is an example of a server. It's actually very huge. It's very huge, extremely huge. And then you have other examples. These are just hard drives because we need to store data, and so on and so forth. So your server has to be extremely fast, extremely it has to have a lot of resources like RAM, storage, and network or internet access. Apart from the server itself having all those resources, your ERP application needs to be configured in a way that it can handle all those requests. Okay. Now, assuming you want to design this and give it to an AI agent to develop everything, what kind of prompt will you come up with? Okay, what kind of prompt will you come up with? And we'll get back to that in a second. So this is just basically the architecture of software we use in the real world. This is an example of an ERP software which basically helps a company run its business. This is an example of a web app which has the website and a mobile app, and so on and so forth. Now, in all these examples I've given you, these three factors here remain the same. Your application has to be scalable, it has to be secure, it has to be fast, it has to be reliable. If you look at this example I gave you right here, this one right here, assuming we don't want the receptionist to see how much money the employees are being paid, that information will only be shown to the managing director. It will not be shown to the receptionist. If we have somebody in housekeeping who helps keep the office clean, they don't need to know how much the managing director earns or how much the finance director earns. So that information has to be highly secure and only delivered to the managing director. Now, you would imagine these are computers in the office. If a customer comes with their own laptop and they connect to your network, can they see everything happening here? No, they shouldn't be able to. Okay, so it has to be extremely secure. So yes, Technovation, this is what you call role-based access control. So you limit how much information somebody can see depending on their role in the company or wherever they are. So now let's take a step back. How did we used to build websites before the AI boom came along? So right here, like I've shown you, this is the Chakula system, and I'll just show you the code I have. So this is what you call, this is the Chakula API. It handles the main API. Okay, the main not the main, but all requests will go through the API. And as you can see, it's a whole project on its own. So we have things like middleware, we have the database connection details here, we have the authentication here, we have the routes. Where are the routes? So we have the users, and inside users I can try and see how can a user log in. So for the user to log in, they will use this endpoint. To register, not to log in. To register, they will use this endpoint. To log in, they will use this endpoint, and so on and so forth. So this is just the API. I'll close this window for now. Let me just shut everything down so that I don't mess myself up. So I'll say down, remove orphans. Don't worry about this. So I'll close this window. Yes. And then we have the Chakula knowledge base. This is now our AI, whatever, the one that handles the food generation and whatnot. So if I want to generate a particular food, I know for a fact I can come to the routes module, I can come to the foods.py, and then inside the foods.py, I have these endpoints, these API endpoints. I have the generate, which basically just generates the food. I was trying to create another API here, whereby instead of generating the food using AI, a user can also generate the food themselves. So if you add, for example, personally, I like to experiment in the kitchen. So sometimes I would even just cook eggs, put them inside mandazi with my tea, and I'm good. So I might want to add it to the platform. Okay, the AI itself cannot know that because that is information I have and I've never shared it anywhere. So I would want to add it to the platform. So I have created an endpoint that does that here, and so on and so forth. So we'll just close the knowledge API. And finally, we have the mobile app. This is the source code for the mobile app. So as you can see, this is the home screen, and I can just scroll to the bottom and see what contents are being showed in the home screen. So if I just scroll. I'm looking for something here. I'm not seeing it. Yeah, anyway, so this is the home screen. This is the suggestion screen, which shows you the suggestions. And I've written the names here. I've named these files as per what the file does. Now, if you pay close attention, this is not .js, this is not .py. So it's not Python, it's not JavaScript. This is a programming language called Dart. It's Dart programming language. It's used for web apps, mobile apps, backend, and so on and so forth. But I use it primarily for mobile apps. It's the same language that powers Story app. So this is the source code for Story, for Chakula, sorry. So I will close this right here. And then right here I have, let me just move this to this side. So right here I have a simulator. This is just an Android simulator. It helps me test mobile applications without connecting my physical device to the computer. I will explore all this when we get to the mobile development part. So assuming we want to build our own system, we want to vibe code our own system, okay? We don't want to write any single line of code. We want to vibe code it. I didn't research much on the tools available for vibe coding because I wanted this lesson to be as objective as possible. I didn't want to go through a tool, get all the bad sides, of that tool and share it here. So we are going to explore what tools are available for us to vibe code. So first and foremost, let's draw the architecture of what we want to build. What should we build? I don't even know what we should build. What should we build? What do you guys think we should vibe code? I know. Let's vibe code a platform that helps us track stolen phones. Okay. So our platform will have a mobile app. So we'll just say, and we can call it Phony for lack of a, no, that sounds weird. Stealer. For lack of a better word. So you'll say this is the Stealer mobile app. This is the Stealer mobile app. And then we have another one, now the Stealer website. The Stealer website. Like so. And then we have our backend. So we'll just delete all this. We delete all these, we delete all these. So it's actually a simple platform because I don't want to complicate it. So we just have our backend here. Backend. All right. So the backend and the database there. I will feed in more details as you continue. So the user will open the mobile app. Ride hailing. Let's do ride hailing. I like that idea. Let's change from this to cabby, for like cab, but cabby for lack of a better word. So this is a ride hailing service, just like Uber and Bolt. So we'll say ride hailing platform. Okay. So what are some of the things a user will be able to do on this platform? So I will open my notepad here. And we just want to have a documentation of what the system will be able to do. So the user will be able to register. And when they're registering, we want to capture their name, phone, email, location, and what else? Let's say, for example, our ride-hailing service will only match riders with drivers whom are within the range of whatever of their. Does that make any sense? No, let's not complicate it. So this is for a user, and we will say, instead of a user, we'll say rider. And then we have a driver down here. Let me just zoom in. And then we have a driver. So again, the driver will be able to register. And then when they're registering, we'll get their name, phone, email, location. But for a driver, we want to get more information. So we want to get, like, for example, the type of car. We'll leave it at that. And then what will the rider be able to do? So the rider will be able to request a ride. So they'll be able to enter location, enter destination. System will be able to okay, let's just say enter destination and book a ride. Now the system will the driver will be able to get notified on booked rides nearby. They'll be able to confirm ride and pick up. So after the rider has been, you know, transported to whatever they are going, they'll be able to make payment using M-Pesa prompt. Let's get crazy. M-Pesa prompt and Visa and PayPal. All right, so this is what the rider will be able to do. This is what the driver will be able to do. So the driver will receive funds in their account. So what else is missing here? What else is missing? So these are our features. What else do we need? Apart from this, if we just take this and we give it to the AI, it will do wonders. Okay, for lack of a better word, it will do wonders. So we also need to tell it which tools to use. So for the backend, we want it to use Express.js, or we can just say Node.js. We want it to use Redis. We want it to use SQLite. SQLite 3, okay, as our database. And then for the front end, we want to have a mobile app, and for the mobile app we use so many tools to do that. We can use something called React Native, and then for the website we will use, so React Native is for the mobile, and for the web we will use Next.js or React.js. What else is missing? So you've seen me mention this Redis here. What does this do? Redis sort of just tries to, it's a caching layer, and we'll get to that when we dive deeper into backend technologies. It's a caching layer because we don't want all the requests to hit our backend. I'll just explain to you in a second. And then SQLite is basically our database. Now, one thing is missing here, because you have built your project, you have not hosted it. It's just built. It's locally on your laptop. You cannot share it with, you know, somebody in another country so that they can be able to book a ride and whatnot. So what else are we missing here? All right, so we'll just keep it very simple for now. Let's go with what we have right here. Now, let's explore what tools do we have. There are so many tools. There are tools you can use on your browser. So you can just go here and say Vibe coding web platforms. And as you can see here, I've not visited any of these links. So it's just, I wanted to do this, I wanted it to be like, from scratch. So we have Google AI Studio. We can open it in a new tab. Vibe coding for everyone. We can also open this. And there's one that is commonly used. What is it called? Lovable. Vercel. Okay, there's quite a few. So, and then there's one called Lovable. All right. So we will explore these three tools for now. Now, build something lovable. Create apps, website by chatting with AI. Again, I'm not asking this tool, too much of it, because it clearly says here, create apps and websites by chatting with AI. That's all we need. So we'll copy our requirements like so. We need to add some little bit of information here. So we're going to say build a ride. Is it ride or cab? Hailing service. The details are as below. All right. Nothing too fancy, so we'll just copy this and then we give it here. Why can't I type? What is wrong? I cannot type. I think it's still loading. So what exactly is taking all my internet? Let me see. So let me just quit that. All right. So it's still loading. We'll go to this platform. This is bring anything to life, build, fast forward anything, turn your ideas into real apps with Gemini in Google AI Studio. And then you have build your first app. Build my first app. Let's go. Again, we are starting by simulating a total beginner who does not know anything in tech, because that is what they are selling the idea online, that you can vibe code a platform without having any experience in tech. Now, remember, that is already misleading, because if you look at our requirements here, this shows that we already know some, we have some little bit knowledge in this thing. So in fact, in the prompt I'm going to give the builder, I'm going to exclude this. I'm only going to use this because this indicates somebody who does not have any experience in tech, but they know that they want this application. Okay, so I'm going to copy this. How can one choose the best technology to use? Please remind me to answer that so that I don't. Let me write it down. So we'll use backend, for example. So skip. I don't want all that. So describe an app and let Gemini do the rest. I will copy this here. I'll say build a ride-hailing service. The details are as below. So we've not even said we want a mobile app or we want a website. We've just said build it. So we'll say build. Show me notification when you're done. So we let that cook. We'll go to another platform. What will you build today? Create stunning apps and websites by chatting with AI. Again, we'll give it the same thing. We'll give it that. We say build now. Why do I have to log in? Come on. Okay, I can log in. So let me say, I think I need to add my other account here for Soma stories. So let's give it a second. Oh, you want me to paste the whatever? So let me just copy paste. Right there. Oh no, I cannot copy paste in the charts. It has a limit of how much I can copy paste. I think I'll share it later. What's happening? There is an ongoing login attempt in a different tab. So where is the tab? The website itself is, there's a pop-up request here. So this pop-up, I have to allow it done so that it can open this. So I'll do it again. Okay, let's check the AI Studio thing if it's done. This one is still loading and I still cannot type. I don't know why. So let me just refresh again. So we'll go to this one and see what it has done. So let me just, okay, what's not happening? Okay. So it has even given our app a name, which is cool. Ride Swift, your real-time ride-hailing platform. Let me zoom in. Why okay, fine. Fine. Firebase, you want Firebase? Enable Firebase. Again, this is a beginner. They don't know what Firebase is. Okay? And Firebase will mess somebody up. if you don't know what it is. uh, So we let it continue doing its thing. We'll go back to this guy here. Now this one is not working, so I'll just do a hard refresh and we paste it again. We paste the content again right here. Sign in with Google. Okay, sure. Go ahead, continue. Authenticating. Perfect. So we let this one cook. Let's see, is this one done? No, it's not done. So while all this is happening, I also want to explore another tool which is very common, Cloud Code. So I do have Cloud Code installed here. Now Cloud Code has so Cloud Code, of course you can just install it. If you're on Windows, you can just go to Cloud Code. There's a download icon, you can download it and install it. Cloud Code has different versions here. It has the chat, the co-work, and the code. So the co-work, basically it does things on your computer. Let's put it to task. Open new Chrome tab. All right, let's see how that works. Yeah, Cloud Code is so let's see. Open new Chrome tab. So with every AI tool, for it to be able to accomplish the task you give it, it needs to sort of like make some weird addition to the tool. So it looks like Cloud Chrome extension isn't connected right now. Here are a few things to check. Okay, we'll just skip all that. And then we have the code mode here. Find a small to do in the code base and do it. So here we are going to paste the same thing. Build a ride hailing service. The details are as shown below. So we'll hit enter. Oh no, I'm supposed to be, let me try the co-work because the code is not working here. So let me try the co-work. So I'll type the same thing here. And then we'll go and check our friend here. Again, it's still doing its thing. So Firebase blueprint is installed, src firebase.ts, Firestore rules. So we don't know which language it's using, okay? We'll just wait for it to finish and then we run our code. This one is still working. I think I saw a notification here. So what type of output would you like for the ride hailing service? Web app, HTML, JS, React app, technical document. Again, if you don't know anything about software engineering, would you know which option to choose here? You would not, because you might say, sure, let's go with the recommended, and then you go to the next thing. Which map location provider should we use? Should be used for showing routes nearby drivers. Let's see. Let's use, again, if you don't know what these tools are, you'll just choose the recommended one. The recommended one, Google Maps, is expensive as hell. It will cost you money. So in my case, I'll choose this one because it's free. Oh no, wait, I want to use a placeholder. So I'll use a placeholder. Which payment method should be included in the prototype? M-Pesa, STK, Visa card, PayPal. Done, continue. Now, keep in mind, I'm using Cloud Code, the premium version. So I can just come here and look at my usage. So I'll come to, where do I see my usage? Settings, is it here? Usage. So as you can see, I'm at 6%, for the current session. And this will reset on Sunday at 8 p.m. It's right here. Pay attention to this. And my subscription is the $20 one. which is like I think 2,300 or 2,200 Kenya shillings. So so far we have 3 tools building the same thing. This one is building, it's still thinking. This one, oh, this is done. Okay, interesting. This is done. And then we have Cloud Code here. Cloud Code is still working. So let's start with the one that is done. So we'll go here. We'll say geographic location access request. This app requests access to geographic location to work properly. Do you want to allow geographic location access? Yes, allow. And then this is our app now, okay? So it's just right here. So we can say move with ride swift, reliable rides at the top of a button. Join thousands of riders and drivers today. Okay, that's it. There's nothing else. That's it. Okay, so let's look at the notes. Support for both riders and drivers with unified login via Google authentication. Real-time ride lifecycle, can enter destination and request a ride, receive instant notifications from nearby requests and can accept them. All right. Click continue with Google to authenticate. Choose your role, driver or rider. Provide your phone number, blah, blah. I've set up prototype security rules to keep the data in fast to safe. They are designed to be secure by enforcing ownership and role-based access. However, you should review and verify them before broadly sharing your app. If you'd like, I can help you harden these rules further. No, I do not want you to do that. So let's continue with Google. So find Moses Mbadi. Say continue. So we'll say I want to be a driver. Let me give my phone number. 815. My car is an SUV. The number plate is KDX 111X. Get started. Waiting for request nearby. Now I want to share this with you guys so that you can see if now you see I don't even know where to go to share it. I mean, there's a publish here, so we'll say publish. What does publishing look like? Your website, your chat history, code will stay private. Your app will be accessible via a public URL. Get started. Yeah, I need to set up billing for this thing to work. Okay. Okay, let me go ahead and set up. No, I'm not going to do that. I am not going to share my billing information with you guys. No. Are you taking ages? Man, I do not want to share my billing information. So, yeah, I mean, sure, you can share it as they say, and it will work okay. But I want to draw attention to something interesting here. As you can see here, the application is very basic. It's just there, it looks like it was designed by a software engineering student. Now, you can try and give it further prompts to make it look better. Like you can customize this one right here. You can add as much information as you want. Like for example, what colors to use, what fonts to use, what the navbar should look like. But again, the point here is, if you want the AI or whatever, AI agent or AI tool to give you a nicely polished application, you have to understand what you're doing. You have to understand software engineering. For example, if I want to say for the navbar, I want to use a different icon set. I want to use, what will you say? So let's say icon. So I'll say I want to use a flat icon, or I want to use font awesome, or I want to use, I don't know what these things are, or bootstrap icons. So for me to do that, I need to be able to have some experience with software engineering. Okay. keep building your momentum. Okay, so my tokens are over, I guess, my free tokens. You just ran out of tokens. Upgrade your current plan to keep on building. So it's $24 per month, which basically gives you these tokens. Again, we don't know what tokens are. There's public and private projects, no daily token limit, start at 10 million tokens per month, no bolt branding on the website, share site. Well, too much information. I don't need to go into all that. So you've hit today's free limit. So again, at this point, I'll have to wait for the limit to recycle so that I can continue with my work, or I can just pay for it. So I'm not going to pay for it. So the conclusion here is, if you want the service, if you want the tool to be accurate and to give you something that you can deploy, number one, you have to pay for it, and number two, you have to be very, we call it verbose. Like, you have to tell it everything. You have to tell it the colors to use. Like right here, I see it just used black and white. And there's a green here. The profile icon does nothing when you click on it. When you click on a profile, in a normal web app, it needs to do something. Like, it needs to, open the settings, the details information, and what the profile details. So if you want that as well, you can add that information here. Now, what does this system document look like? We'll look at that in a second. And then, so that is the conclusion we've drawn here. Now, the conclusion we'll draw here, if you want your project, you have to pay, which is about $24 a month. Okay. Cloud Code, let's see what it has done. Again, as you can see, my usage has just jumped to 24% from, what was it, 3%. And if I exhaust, I have to wait for another 4 hours for me to be able to continue doing my work. Okay. And it will do that as I continue. So it will reset at 4 hours, and then I have to wait for another 4 hours, and then I have to wait for another 4 hours, like so. I think it changes. It can be 4 hours, 2 hours, depending on when you're doing it. So let's look. So Cloud Code is still writing. Let's wait for Cloud Code and see if it will come up with something close to what we want. I think I'll go make myself some coffee. Where are we? Great choices. I'll build a full home. View. This is the HTML. Driver flow, register name, phone number. Okay. Cloud Code has tried this. Some little bit of color. Yeah, because the paid version is not, like, it's not unlimited. So right here, I'm under the $20 plan. If you want something more, you have to adjust your limits. So if you go to Cloud Code pricing, So if you go to cloud code pricing, you'll see the prices, okay, and the number of requests that you can do. So there's a free version, of course, you can use the free version, but it's very limited. And then there's this is the $20 one. It's $17 if you pay yearly. And then they're just saying here more usage. It does not show that the tokens are limited. And then here it says 5 to 20 times more usage than Pro. So it depends on the usage. So let's go and see what it created. So this is what Cloud Code created. And we can open Chrome. So let's do that. And there is nothing here. It is not working. So it did build the website. We can see it here. So let me try to log in as a driver. Let's say driver@mail.com. And then we'll give it and sign in. All right, so Cloud Code tried. It's a little bit nice looking, but so when we tried the Google one, if you noticed, it only had the registration using Google, like sign in with Google. There was no email and password, which does not make any sense, because in the real world, not everybody wants to use their Google account to sign in into things like this. So we can sign out. So nearby rides, earnings history, where you'll see your earnings, today's statistics. So let's just sign out and try to log in as a rider. So we'll say rider@mail.com. 798 351 let's try. All right, so the map is not showing location, destination. So let's say Kiambu. Find rides, and we can find rides here. We can say that proceed to pay. Let's see if the push notification is working. Okay, so you'll enter the M-Pesa number. I'll say push sent to this number, M-Pesa confirmed, driver is on the way. There has not been a single push notification on my phone, so the push notification is not working. All this is demo content. Okay, so this is what we call a prototype or a proof of concept, and it's what AI or vibe coding is really good at, creating a proof of concept for you to practice with. So the driver is arriving, but there is really no driver coming. It's just some demo content. So Cloud Code tried to go a step further. They did add some color in there. They did add some demo flow so that you can see how the flow will be, but it's not what the M-Pesa has to work. The map has to work. Okay, so the conclusion is you cannot build anything sensible using vibe coding. The most you can do is just use just create a prototype and then build on top of that. Now these other tools, the online tools that we've seen, like this one right here, so you either have to wait for the tokens or for your usage to reset, or you have to pay. Now the problem is, in the tech world, there is something called vendor lock. You start using a specific tool for to achieve something, and then they charge you $24, and then you put all your data there. 3 years later, you have 100,000 users. They tell you, now you are paying $2,000 or you're paying $200 per month, but if you get to 100,000 users, you have to pay $1,000. Okay, now you ask yourself, $1,000 is a lot of money, I cannot afford that, so let me move to another platform. You go and try to move, but you cannot even copy your data, because for you to copy the data, you have to go to, you have to subscribe to the $1,000 plan. So that is what you call vendor lock, and it's very common in tech, especially in search tools. So we have something like this. It gave you something, looks usable enough. There is home, activity is not, there is empty, waiting for request nearby. I don't know what that means. and then there's account. There's also a bunch of code here. There's no clear distinction between the back end and the front end. There's no caching. There's no firewalls and what we call rate limiting and whatnot. All this is missing here. So the bottom line is, before you build any platform, write down the requirements of that platform, what you want that platform to do. Oh my goodness, why did I delete my diagrams here? Control Z until we get to where we were. All right, so in any systems, like for example, if you're building Chakula, or if you're building something like Story App, there are all these services that are interdependent, okay? Each depends on the other service to work correctly. So for the reverse proxy to work, it needs to have the API working. Where is the API? My goodness, I deleted the API. All right, so you have the API here. So for the backend to work correctly, or for our main API to work correctly, it needs access to a database. For the reverse proxy to work correctly, it needs access to the API. For the firewall to be able to prevent cyber attacks and all that, it needs to be well configured, like I've just shown you with Coop Bank and with Soma stories. And then you also need other helping services, like for example, Mobi here, which basically handles communication. Is it really communication? It handles push notifications, emails. It handles recommendations. Actually, this service handles recommendations. If you download Story app right now, and you download the app on your friend's phone, and you both choose different tags, it will only take less than 30 minutes for the system to learn what you like, and for it to generate for you different stories from what it generates to the other user. Now, if you were to create a document that explains all this so that you can give it to an AI agent to write for you, you need to be able to understand these things. And for you to be able to understand these things, you need to be able to understand how to code, you need to be able to understand how these things work, how they depend on each other, and so on and so forth. So, the AI agents have, improved tremendously, especially in the past 1 year, but we are still way far, we are still, there's still work to be done for us to be able to get to a point where you can just take a diagram like this and give it to an AI agent and have the AI agent write the entire code for you. Okay. Yeah, that was my presentation. That was my class. Any questions? All right. So before I end the session, I have mentioned a few times that I rarely write code, but I know how to read code. I know how to identify which file does what, which line of code does what, and I use. Let me just show you what I use. So inside VS Code, like this is the Chakula mobile app. So inside VS Code, I have Cloud Code and I have GitHub Copilot. GitHub Copilot is of course free. It's free, but it's a little bit weak. It will not give you accurate answers and whatnot. And then I have Cloud Code here. And of course I have my code right here. So what I do is, if I want to change something, for example, let me just fire up the project. Let me say Flutter run. I have to so I have to launch my emulator. So I'll come here, virtual device, and then I open the emulator. All right, so if I want to change this to something like, what should we call you, instead of what's your name, Okay, I'll need to be able to find out exactly where this file is. Without the help of AI, I can just come to my modules and look for that specific screen, which is the onboarding screen. We call it onboarding screen. Again, you wouldn't know what name it is unless you've learned your user interface and user experience design. So I'll come to the onboarding module here, and I'll go to the name screen. This is where we ask the user for their name. So I can just scroll and look for that text. What is your name? Like so. So sometimes you cannot find it, like what I'm doing right here. You cannot find it. So I'll go to the mobile app and get the text. What's your name? So I'll come here to the search. I'll say, what's your name? Nothing. So I'll delete that. What's your? And then I can see it's under the budget screen, and it's also under the name screen. So I'll go to the name screen, and I'll see it's right here. What's your name? So I can change this to, I can change this to, oh my goodness, what am I doing? Let me just go back. I was right here. Why didn't I see it? So I'll change it to, for example, what should we call you? What should we call you? Now let's see if it has reflected on the app. So we have to run the app first. So we will do the same thing using Cloud Code, and then we will pay attention to our tokens. How much tokens will be, not really how much tokens, but we'll pay attention to our usage. So the project is relaunching, and then as you can see, what should we call you? So it has changed from what's your name. Now, assuming you don't know how to code, you don't know how, you don't know what all these things are. You just want to talk to Cloud Code. So we can go to Cloud Code and tell it to change. So we can say on the onboarding screen, instead of saying what should we call you, we want it to say welcome name. Okay, we want to be nonchalant, so we'll say welcome name, like so. So we'll go to Cloud Code and look at our usage, where we are at. So we'll go here. So right now we are at 34%. Okay, the reset timer still remains the same. So we'll go back to the code. This is Cloud Code, and which agent are we using? We want to confirm the agent we are using is Cloud Sonnet 4.6. So we'll just hit enter here. Oh wait, I thought I had already configured this. So let's just sign in. What is happening? Okay. If the browser didn't open, visit this URL. So let's just copy this. Let's go to the browser and let's paste it. Authorize, copy code. Let's go back to this. Let's paste our code there. Continue. Failed to authenticate, invalid authentication credentials. What do you mean? What is not happening here? Let me try again. So why are you saying you failed to authenticate yet you my goodness. All right, so we were at 34%, remember. So we'll say yes, continue. The heading now shows welcome and updates to welcome name as the user types their name. So as you can see, it did not even understand my instructions. I did not want it to use the name as a variable. I just wanted it to say name with a question mark. So I'll go back to my code. I will refresh my project here, and then we'll see welcome. I wanted it to say welcome name with a question mark. Okay, it missed that. So let's look at our usage right now. Let's go back to cloud code and look at our usage. So it was at 34. We refresh. We are at 35. So it has consumed 1%. And remember, for 4 hours, that 1% is very important. Now, it has not done exactly what we wanted it to do. So we have to again tell it, no, we want it to say, welcome name. All right. So I'm trying to picture myself as somebody who does not know how to code. So I will not tell it, don't use name as a variable or name as dynamic. So I just say I want it to say that. I will hit enter. Again, it does the calculation. Now, I also want you to pay attention to the amount of time it took for me to change the text when I was not using AI to now when I'm using AI. So let's refresh. Again, it did not do what I asked it to do. This is frustrating. Look at this. Let's read. Done shows welcome when empty and welcome name as the user types. I don't want the user to type for you to show the name. I just want you to say welcome name question mark. Okay. But again, the feature is nice. The feature it has added is nice. So if we say, for example, Moses. So if you say Moses, I thought it says the name will display as the user types. Okay, again, we are still not yet there. For a very simple change, let's look at the number of, let's look at our usage now. Let's refresh. We are still at 35% because it just edited whatever was there before. So let's go again and tell it, we want you to display welcome name. Okay, let's act a little bit frustrated. No, we want it to show welcome name. Okay, I mean, I can end this madness by just saying don't use name as a variable or don't set name as dynamic. But again, for somebody who does not know how to code, they don't know what dynamic is, they don't know what a variable is. So you just have to fight with it until you get what you want. So you say, we want it to show welcome name. Exactly like this. Welcome name. All right, hit enter. And mind you, I'm using Cloud Sonnet 4.6. It's like one of the latest versions of Cloud Code of Anthropic. It's like super powerful. It's not weak, but as you can see, it's struggling to understand my instructions. So done. The heading now statically shows welcome name. So we refresh our app. Yeah, welcome. Now it has taken three prompts, a headache for it to just change the text to whatever I wanted it to change to. Let's see if the usage has changed. So we'll go back to the browser, we refresh. Yeah, we are still at 34%, 35%. So we've used 1% and it has taken us over 15 minutes for something that I just went into the code and changed because I understand the code. Okay, I understand if I want to change the name, I go to the name screen, I go to this file right here, I change that name. So final verdict. What is the final verdict? You cannot vibe code a fully functional web app. You cannot. Okay. Number one, for you to design any system like I've shown you. So for example, if you are talking about the cab hailing service, okay, this is what we'll need our platform to look like. There are over 2 million users in Nairobi every day. I'm guessing that number. There are over 2 million people in Nairobi every day who want to use cabs. Okay, let's use a fair figure. Let's say 100,000 people who want to use your platform every day at 5 p.m. to request a ride. That is 100,000 requests coming to your backend, okay, within seconds. And it's not just 100,000 requests, because somebody might just want to check their profile, somebody might want to check their balance, somebody might want to check the location of the rider and whatnot. So for one user might make as little as 10 requests a minute. Okay, so if you say 10 times 100,000, that's close to a million requests. Is that a million? What am I saying? Is that a million? Yes, that's a million requests. So your backend is getting a million requests a minute. Now, from the prompts that we've given these AI agents, none has put in place infrastructure to handle that many requests. They've just told you, we've created this, go to this link, pay if you want others to access your application. Okay, there is no rate limiting, there is no caching, there is no database backups, there's nothing of that kind. And that is not how applications work in the real world. Like, for example, this database you see we have here, in the real world, it's not just one database. You have multiple databases, all synchronized or all having the same data. That is how, if one computer containing that database fails, Co-operative Bank cannot call you and tell you, hey, how much money did you have again? We've lost our database. You know, the same way people lose chats on WhatsApp and they're like, text again, I lost chats. Co-op Bank cannot do that, okay? If their offices right now catch fire, you know, if their main office, you know, God forbid, goes up in flames, their data is backed up somewhere in the cloud, okay? They can just retrieve the data and they continue with their operations. The same thing applies to the API here. It's just not one computer handling your request. There are like 3 or 4 computers handling your request all at the same time, okay? There's something called load balancing. We look at that when you get into cloud computing, okay? So again, if you want to develop a web app, draw these features down, okay? Come up with something like this, and then put it in words, and then give it to the AI agent, and then try and see if it will create all these things in one go without you touching a single line of code. It's impossible, not with the technology we have right now. I mean, sure, a year, 2 years from now, maybe the agents will become better. We'll just tell an agent, hey, build me a profitable business, you know, and deploy it to AWS or Azure or whatever, and it does exactly that. But for now, dear brethren and sisters, learn how to code. It will save you a lot of headache. Yeah, so that's it for this session. This is part of the self-taught computer science course that we have on YouTube. If you are here for the first time, you can have a look at, you know, the courses. All the recorded sessions are here on YouTube. You can just start with class 0, moving on to class 14. Our next class will be on Saturday, where we look at databases, okay? This thing you see here, we look at databases. What is the essence of databases? How to plug into our backend, how to set up good disaster recovery. Disaster recovery is like, you know, having backups and whatnot. If your computer crashes, do you have a backup of your database? And so on and so forth. It will be a super interesting class. I'll see you on Saturday. Bye.